Welcome to the last and final section of distributed deep learning. In this section, we'll take you through how to train, tune, and serve your model in the cloud using Google Cloud Machine Learning Engine. In this section, we'll input our data and represent our features using TensorFlow's latest features. We'll design and package and train our TensorFlow estimator model in the cloud. We'll also tune and improve our model using hyperparameter tuning. We'll also create a production-grade cloud prediction service using our trained model. Our dataset. We'll be using the Microsoft Trajectory dataset linked below. And basically what this is it provides us with a GPS point, some information about that GPS point such as altitude and date, and a mode such as walk, bike, drive, or train, in order to give us an idea of what those people are doing at any given point in time. The question we'll be asking ourselves is, can we predict what mode someone is taking based on the dataset's attributes? So we'll ingest data using TensorFlow Datasets API. We'll represent data using TensorFlow feature columns. We'll also use a wide and deep model to predict transportation mode. And then we'll deploy and create an API for our classifier so we can provide predictions into our products. Looking at the higher level TensorFlow approach, which really emerged after TensorFlow 1.5, but I've updated here so it supports 1.6 as well. Looking at this, it steps through TensorFlow datasets and feature columns, and finally estimators to do all of our training, evaluation, and prediction. Looking at it from the Google Cloud perspective, what you learned in the last section was how to use workers and parameter servers and masters. In this part of the course, Google Cloud Machine Learning Engine will do all those things for you automatically. You'll just focus on getting your model ready, and I'll take you through the steps needed to do that. In this section, we'll be using a wide and deep model. Now, to give you a little background on wide and deep models, they became popularized a couple of years ago when we needed to understand what a deep learning neural network was doing and also try to get the benefits of shallow models like linear models. So think of a linear model, which is a linear combination of features, and how easy that is to describe what those features are doing and how important each feature is, and combine that with a more complex model understanding of different features and their interactions and combinations of those interactions, including embeddings, and using a deep neural network combined with a linear classifier, you get a wide and deep model, which gives you the best of both worlds. I've included a link to the paper below if you want to find out more.